What's up, guys? Welcome back to the channel. In our last video, we set up one of the core services in our environment, and that is DNS. In today's video, we'll be moving on to another critical piece, and that is our certificate authority. We'll be working with Step CA, a lightweight modern CA developed by Simple Steps. It makes it super easy to issue, renew, and manage TLS certificate for your internal system, giving you the full PKI control. I've seen a lot of videos on setting up SSL for your lab environment, but I'm taking a slightly different approach. There's nothing wrong with the way others do it, but I'm a big believer of keeping everything internal first and only making things public after you've tested and validated your setup. It might be the harder route, but it gives you time to build in peace, learn how everything works, and only go in public when you're ready. And this setup is basically going to reflect that. This will happen in two phases. Phase one, which is this video, we'll set up our internal certificate authority with Step CA and explore how SSL work, what certificates are, and how to build your own. This is a very important skill because instead of just grabbing a certificate from a public CA, you're building your own trust chain. And that, my friends, is what Homelab is all about, leveling up your skills and understanding how things work. In phase two, which is going to be the next video, we'll buy a public domain and use it to get a wildcard certificate from a public CA like Let's Encrypt. Then we'll configure an internal proxy to use that cert for SSL termination. To make this work internally, we'll also set up a local DNS zone that mirror our public domain so internal systems can resolve the same domain name to the internal IPs. This lets us use a public trusted certificate inside our network without pushing our internal CA to every device. Everything stays private and internal, and we'll only update the public DNS when we're fully ready to go live. This is going to be a longer video. All of my videos are long. I feel like this is going to be a longer video. So as always, I've added chapter below, so please feel free to skip to the part that interests you the most. I know some of my videos, well, I know most of my videos, if not all of my videos, are pretty long, but that's because I try to be as detailed as possible. So chapters below, jump to whatever chapter interests you the most. Also, make sure your DNS is already set up since you'll be relying on it throughout this process. If you haven't done so already, if you haven't set up your DNS yet, I do have a full video, a really detailed video about how to configure your DNS in your internal network. Link will be in the description box below. You can go ahead and check that out. As you can see, there's a lot to cover. So let's go ahead and jump into phase one. Before we get into the config, let's first break down what PKI, public key infrastructure, actually is. It's not just about fixing the connection isn't private warning in your browser. PKI is what secures data in transit. To understand PKI, we first need to understand the relationship between a client and a server. When a client, like a browser or an app, connects to a server, like let's say a website, it needs to know one thing before sending any sensitive data, and that is, can I trust this server is really who it says it is? That is where PKI comes into play. PKI uses digital certificates and trusted certificate authorities, which are normally called CAs, to help the clients verify the server's identity. If the certificate is valid and signed by a trusted CA, again, certificate authority, the client says, cool, I trust you, and the secure communication begins. There's a chain of trust involved. On the top of that chain, you have your root CA, which is your root certificate authority. This is the top level certificate authority. It's the ultimate source of truth. And usually when it's created, it's normally kept offline. Next, you have the intermediate CA. This sits right below the root CA. It gets its certificate signed by the root CA, and it's the one that actually signs certificates for servers or clients. This kind of helps keep the root CA safe. Last on the list is the server certificate. This is what is actually installed on the server. It's signed by the intermediate CA, and that trust traced all the way back to the root CA. Each certificate is signed by the one above it, forming a chain that the client can verify. Now, let's talk about key pairs, which are the foundation of how certificates work. Each certificate is tied to a key pair. First, you have the private key. This one is kept on the server and it's used to prove the server's identity and decrypt data. Then you have the public key. This is what is shared with everyone. It's embedded in the certificate and it's used to encrypt data or verify signatures. So the way it works is that the client uses the public key to encrypt a secret and only the private key can decrypt it. This is all part of what is called the TLS handshake, which works like this. First, the client, let's say a browser, say to the server, hey, I want to start a secure connection. Then the server will reply back saying, cool, here's my certificate, go verify it. In the certificate, the public key will be included in there. The clients then check its trust store to see if it trusts the CA that signed the server's certificate. If it does, the clients generate what is called a pre-master secret. It then encrypts it with the server's public key and then send it back over to the server. The server uses its private key to decrypt the pre-master secret that was sent over by the client. Both sides use that secret to generate a session key, which is used for the rest of the communication. The session key encrypts everything that follows. Now, one of the things to keep in mind is that the CA, more specifically the root CA, must be in the client's trust store. If the client only sees an intermediate certificate and not the root CA, it wouldn't trust that chain. So when you see a certificate error in your browser, it usually means that the CA, the root CA that signed the certificate isn't in your trust store. The browser can't confirm the identity of the server, so it's thrown a warning. Now, that doesn't mean the connection is unencrypted. TLS is still used. The warning is about identity, not encryption. So your data is encrypted, but you can't be sure who you encrypted to. And that opens up the door for something like a man-in-the-middle attack. There are a few more things we're going to touch on about certificates and trust, but we'll go into those after we stand up our CA. So let's move on to the first step, which is setting up our container and then setting up our certificate authority. Let's go. All right, so to kick off the setup process, we're going to go ahead and create a new container for our certificate authority. We have our test DNS set up here that we set up last week. So today we're going to go ahead and click on here and then click on create new CT. And for the name of the container, we're just going to go CA1. All right, and then we're going to check on privilege container. We're going to make sure that is checked. And we're checking on privilege. So if the container is compromised, the root user on the container is a non-root user on the host, right? The host meaning the Proxmox server. And then nesting is checked because nesting is mostly needed for some system calls, which is probably not going to need it for certificate authority, but it's best practice anyway. So we're going to leave that check. And then here we're going to select our resource, which is test lab. A resource just basically allow you to group things together for permissions and other stuff. So I'm put that in test lab. And then we're going to type in our password that we want to use for this container. Okay. And then we're going to retype that. And then here, if you have a SSH key set up, a public key, you can enter it here. So once the container is created, it's going to automatically go into save that to the .ssh folder. So it will allow you to be able to quickly SSH into the container. But I don't have anything set up right now, so I'm going to leave that as blank. If you do, this is where you put it. And then we're going to go to next, or this guy. And then it's going to ask us, hey, what do you want to use? What template do you want to use? If you remember in our last video when we were setting up the DNS server, we did pull down the Ubuntu template. So we're going to go into Sandbox here, and then we're going to select our Ubuntu template for our template. And then we're going to click on disk. If you're not sure what exactly template is, watch the DNS video and just kind of go to the timestamp at the bottom and then just go to the timestamp as to when I was setting up the container. I did a bit of explaining there as to what templates are. I'm going to select that and we're going to go to next. And then for disk, we don't need that much space because again, this is a certificate of 30. You're not going to be saving a lot of stuff here. So we're going to go to our sandbox storage here, and then we're going to say, let's just give it 10 for now. But to be honest, you need anywhere from 5 gig to 10 gigs because again, this is a certificate of 30. You don't need that much space. And then for CPU, again, you don't need that much heavy of a core on the server. On this container, you can do 1. If you are kind of low on resource, I'm just going to do 2 for now, but you can definitely do 1 again. certificate of 30, right? Not that much needed. Memory, same concept, not that much needed here. So this is perfectly fine. I'm just going to go one up, but 512 megabytes is perfectly fine. So you don't have to worry too much about that if you want to keep it there. And then next, and then for network, we're going to go ahead and select our network here, which is the test VNet, right? And then for your core services, like I said in my previous video, you always want to make sure they're static because you don't want those things to change. So we're going to enter static IP here, which is 10.10.100.4, because I think our test DNS was 3. And then gateway, of course, you have to enter the full CIDR annotation, so 24. And then our gateway is 10.10.100.1. Okay, we're gonna not touch IPv6, and that's pretty much it. I'm gonna click next, and here we don't need to enter the VLAN because the VLAN is already attached to this guy. So we're good to go on that end. So click next. And again, if you don't know some of these things, remember that the whole idea behind this video is just to go step by step by step. I've already created previous video that talk about networking and storage and all this other stuff. So if you kind of lost here a little bit, just make sure you take a step back and go look at those videos and then come back here. We're going to go to DNS. We do have our DNS set up. And for now, we're calling it ktechlab.com just for those two tests. And I'm going to update it. But for now, this is what it's called. And the IP address for that is 10.10.100.100.3. Can't type today. So that is the IP address for that, or the DNS server, or you can just enter the FQDN here if you want, but I'm just going to leave it for the IP. FQDN meaning that the fully qualified domain name, but I'm just going to leave it for the IP for now. And then that's pretty much it. So you're going to click confirm, make sure everything looks right, and then you're going to go ahead and click finish, and that's going to do its thing, and then create the container for us. And then once we see it's doing its thing, give it a couple of seconds, and then once we see task okay, that's perfectly fine. We're going to go ahead and click X, and now we're going to go to this container, and then we're going to start it. So we're going to go ahead and click start here, and it's going to do its thing. Just give it a couple of seconds, and it's going to start starting up. Containers are pretty fast, relatively fast when they boot up, so it shouldn't take that long. I kind of clicked away, but it should be on now. There you go. I think I pressed OK. There you go. So we're going to say root, right, and then we're going to enter our password. All right, so we're in, and then the first thing I like to do when I install something, especially a Linux server or Linux container, is just run some update on it. So we're going to do apt update, and then we're going to do an apt upgrade -y, and this is going to pull down whatever it is updates that's missing, whatever updates that we have hanging on the container, whatever it is that needs to be pulled down, it will be pulled down. That's the first thing that I normally do when I set up a container. So we're going to let it do its thing. And once it's done, we're going to come back and pick up from there. All right, so the update is done. So the next thing that we want to do is we want to add this guy to our DNS server. And the reason for that is that when we set up our DNS, we didn't set it up as a dynamic DNS, meaning that everything that we create in our environment, we have to manually add that to our DNS on file. So our DNS is aware of the server. And the reason for that is that it just allows you to become very familiar with your environment, very familiar with DNS, and you're able to know what's in your environment, what is in your DNS, and you can clean it up a lot more better. And then once the environment starts getting a little bit bigger, we can go ahead and set up dynamic DNS. For now, it just allows us to be able to better understand things, right? So I'm going to see what it should, of course, be pointing. If we go to DNS here, it should, of course, be pointing to our DNS server. And you can check that as well by doing cat etc here and then resolve .conf crnf. That should tell us what name server is being pointed to. Of course, that's the search domain, and then of course this is the IP of our DNS server. So to add this guy to our DNS here, if we go back to networking, or you can just do if config, but since we're already here, you can see that is 10.10.100.4. So we need to go into our DNS file here. I'm going to go to console, and then here we're already in the bind folder, so we're going to do ls, and then we need to go into this guy right here. So what we want to do is nano db k enter, and we need to add this guy as one of our A records. So we need to add it here. So it's CA1, all right, and then you go space here, and then do IN for internet type, and then we do A record here, and then we enter the IP address for this guy, so which is 10.10.100.4, right? And then we're going to go ahead and click X here to save this guy, save that file, click enter. So if we do nano one more time, actually, let's just do cat to see it because we don't want to get into it. Not caps, cap lock is on. So let's do cat. We should see that that guy has been added and this guy is right here. We also need to add it to our reverse lookup zone. So we need to look for that file as well. So if we click ls here, and it's this guy. So we want to add it to this guy as well for our reverse zone as well, to our reverse zone file. So we're going to do nano, and we're going to do db dot 10 tab enter, and we want to say our IP address is 4. And again, if you're not exactly sure what I'm doing here, you take a step back and go look at my other video, which talks about setting up your DNS server and all that stuff. That's kind of important because it's needed for the setup, right? So, and if you don't have that set up, please make sure you go ahead and configure that. So we're going to add this in our forward lookup zone, right? And then there's a PTR record, all right? PTR, and then we're going to say it is called ca1.ktechlab.com. All right, so it's ca1, and our DNS is of course DNS test.ktechlab.com, and then our guy right here is ca1.ktechlab.com. Control X, yes to save, enter. And if we go back here and then go home and just cat this guy, it should be able to give us and let us know that our PTI record has been added for our server. If I was to do something like try to ping the server right now, it's not going to work. So ping, let's say ca1, it's not going to work. It's going to tell me like, hey, I don't know what you're talking about. There is nothing like this in my zone file for me to be able to ping. But that's because you have to restart the bind service for it to take effect. So to do that, we'll do stm systemctl restart and bind 9 enter. That's going to restart the services. Now if I go back and try to ping that, you can see that now it's able to ping it because it's able to look in that zone file and be able to say like, oh yeah, you have a DNS server, you have an entry in your DNS server for that particular server, and it's pointing to this guy right here. So that's perfectly, it's working exactly the way we want it to work. So we're going to get out of this real quick. All right, and if we go back here now, and of course we're going to be able to ping DNS test. All right, and of course it comes back and say, hey, we should have been able to ping this anyway because again it's pointing to that DNS server. So regardless, we didn't need to add this in here to be able to ping the DNS server. This is already pointing to our DNS server, and our DNS server is already in entry. So we should have been able to ping it even before we made that change. But that's the next thing that we needed to do. And now that we have everything working, I'm going to get out of that. Now that we have our DNS set up and everything is working, the next step that we need to take is we're going to go ahead and install step CA on our container, our CA container. Now that we have the container up and running, we're going to move on to installing and setting up step CA along with the step CLI. All right, so we're going to move on to the next step, which is basically installing step CA and installing the CLI for step CA as well. I will have all of these commands in my blog, so you can check the description down below to be able to just kind of copy and paste. Some of them are pretty long, some of them are not. But let's go ahead and kick off the process. The first thing that we need to do is we need to install a couple of tools that we're going to use throughout the process. Some of them are probably already installed on the computer, but just to make sure, we're just going to try to install all of them so we don't have to kind of worry about whether or not they're available. And to do that, we're going to run this command, which is apt install -y curl wget and then gnupg2 and then lsb-release. Okay, so these are a couple of commands, or a couple of tools, I should say, that we need to install so we can go through the rest of the process. Again, all of these commands will be in the blog. So I'm going to go ahead and click enter. So what it's going to do is going to go through the computer. If the tool is not installed, like wget or curl or lsb release or gnupg2, I can never say that right. If any of those are not installed, they're going to go ahead and install them. This is just basically this tool, basically just grabbing something for from the web. This is just basically used to kind of manage and read the public key that we're going to install, and we'll talk about that in a minute. And this one, it just pretty much grabs information or display information for about your OS, because some of those things do need that. So it's pretty much going to go through the computer or the container, and if any of this is not installed, so you can see it's just going to go ahead and install it. The next command we're going to run, which is this guy, this is a little bit long. So basically what this guy is doing is that we add in the simple step repository public key, so our system can trust the package from their repo. So basically what we're doing, we're using a curl to fetch the public key from here, and then we're adding it to this location. And you will see why we're adding it on the next command. So if I click enter and I go back up one, let me just get rid of this and just do a cat. You can see that we'll pull down their public key, and you're going to see why we're pulling that down on this next command. So let me just grab that next command here, and I'm going to clear that out. And I'm going to paste this next command, which is also a pretty long command. The next thing that we're doing here, we're saying that like, hey, add the repository, this guy on our system. So when we do things like app install, step CLI, and step CA, the system know where to find those things and pull them down to our system. But we're not only doing that here. If you see as well, we're saying like, hey, only trust packages that are signed by this public key. So remember, if you remember, that's what we just did a few seconds ago. We pull out that public key and we're saying like, hey, only trust things that are signed by this public key, right? So that's very important, because you don't want to pull down things that are not trusted and you kind of mess up your system. So that's important. So if we click enter, that has been added. Normally after I add a repo, what I like to do, I'll just do app update and just kind of update the system. Next, now we're able to install step CA, and we're able to install the step CLI as well. So if we do apt install step CLI and then step dash CA. So basically what we're doing here now, we're installing step CLI and we're installing step CA. Those are the two things that we need to be able to kind of get the certificate authority working on our container. So if I click enter, you're going to see that it's able to pull that down because it's looking at that repo and it's pulling things down for us. So now step CA has been installed and we're good to go. All right, so the next thing that we're going to do is we're going to need to initialize step CA. So basically what we're doing is that we're setting up a new certificate authority by generating the keys, the certificates, and the configuration needed to run step CA. Those things do not exist yet, and we need to make sure they exist. The common folder for, well, the folder for all of those things would be in the CD root, and there should be a folder in your called step, but it's not there yet, and it hasn't been created yet, and it doesn't get created until we initialize step CA. So if I was to do tab right now, you notice that it will not autocomplete because that folder doesn't exist yet. But even before we initialize it, what we want is that we want to make sure we're aware of what the FQDN for this container is, meaning that what's the fully qualified domain name for this container, because we're going to need that. So if I was to do cat etc host name, you can see that the name of the server is CA1, but we need the FQDN. And of course, that will be, if I can ping this actually, CA1, and it should be able to give us the FQDN. So that's the FQDN for the container. So you're going to need this because we're going to need to enter this when we initialize steps here. So make sure you make note of your FQDN. And again, this is why a DNS is very important, because if you do not have a DNS set up, the only reason why you see this right now is because we have this in our zone file that we set up earlier, and we reference it to this IP address. And you're going to need that because you ideally, when you go into configurations in your environment, you normally don't want to point to IP address. You want to point to your FQDN, because your IP address might change, but your FQDN will not change. And if you've set up a configuration where you put in the IP address and not the fully qualified domain name like this guy, and you end up changing the IP address later on down the line, that will end up breaking a lot of things, and you're going to have to do a lot of digging to try to figure out what's wrong. So it's always ideal to use your FQDN and not your IP. And that's why DNS is so important in your environment. Is not even funny. It just touches everything, and it's the one thing that just just there's tentacles everywhere. But anyways, you're gonna need this. That's enough for my rant for the day. You're gonna need your FQDN, and then once you have that, to kick off the initialization process, we just want to say step CA init IT, and then it's going to kick off the process. So it's going to ask you a couple of things here. It's like, hey, what deployment type would you like to configure? You have the standalone, which is what we want. So basically that is basically creating a CA, which is entirely local on your server, and it's 100% self-hosted. And then you have the link, which is it's not completely local. You have a local CA, but then you connect it to simple steps for things like monitoring and reporting and things like that. So that's one way to do it. And then hosted is where you don't self-host anything, and you have Step CA host everything for you. We don't want that. You can if you want to, if that's what you're going for. We want the standalone because we want everything to be internal and local, right? So click enter. Now, it's going to ask you a series of questions. It's going to ask you like, hey, what do you want to call your new PKI? This is also very important because whatever it is that you call your PKI is going to be in your certificate. So it's best to call it something that is related to your environment, right? So for now, I'm going to say KTech Lab. This is something I have to reconfigure anyways. This is kind of like the test things to create these videos, but this environment is going to be reconfigured. But for now, we're going to call this test KTech or KTech Lab, sorry. So you can call this whatever you want, but just make sure it reference something that's easy for you to remember when you see the certificate, because it's going to place that in there, and I'll show you guys once we have everything set up. Click enter. Next is going to ask you, hey, what DNS name or IP address will client use to reach your CA? It's basically asking you for the FQDN or the IP address for this container, and this is why you need the FQDN for this container. And you can put IP address if you want to, but I do not recommend it, right? Because and that's something I know that some, like when I set up the DNS, when I was configuring the DNS, I say you can put your IP address, but it's always ideal to put your FQDN instead of your IP, because it's just better that way, just in case you have to change your IP. I don't mean to sound like a broken record, but something to keep in mind there. So we're going to enter the name of this container. I'm going to click enter. It's going to ask us like, hey, what IP and port would your new CA bind to? We just want port, we want TLS, so 443. You don't have to worry too much about the IP because, again, it's already referenced up here. So you have to do colon, and then you have to do 443 because that's TLS, right? SSL. So colon 443 is perfectly fine. And you click enter. And it's going to go to the next one and say, what would you like to name this year's first provisioner? The provisioner is very important. The provisioner is the account that is authorized to request and manage certificate from the CA. This account is very important because every time you need to sign a CSR, and we haven't talked about what that is, but we'll talk about that in a minute. Every time you need to sign it, for simplicity's sake, let's say every time you need to sign a certificate, right? That's not what it is, but just for simplicity's sake, every time you need to sign a certificate, you're going to need this user. And this is the first one that's created. You can create another one after you set up your certificate of 30, but this is the first one that's created. So make sure you remember the username. Well, normally when you want to sign it, it's going to give you the username, but just make sure you remember it and you remember the password. This password is very important, so make sure you save it and make sure the password is strong. And that goes for anything that have to do with your certificate of 30. You need to make sure all of your password and things that needs to be private are private and you don't share it with anyone. So for now, I'm just going to call this admin and then click enter. It's going to ask us like, hey, what password do you want to enter? Again, make sure the password is strong. I'm going to paste that in. And then click enter. The password has been created, and now you can see our certificate of 30 has been set up. So it's telling us a couple of things here. It was like, hey, this is where you'll find your root CA. Most of the time you will need your root CA, and I'll show you guys that in a minute. It will tell you like, hey, this is where you find your private key, and the private keys are very, very, very important for you to never share your private key to anyone whatsoever. Because again, the private key is very important, like we talked about earlier. So normally you want to create a backup of this, save it offline, and do not share it with anyone. You have your fingerprint, and then you have the intermediate certificate here, right? So again, this is your intermediate certificate, and this is your root CA. So remember what we talked about. The root CA is up top, and then the intermediate certificate is at the bottom. of the root CA, and then you have the private key for that as well. And then you have the database, and you have the config file here. This is like the default JSON config, and you have some of the other config file here that kind of define how steps here work and all that other stuff. So let's jump to this folder. So if you remember, this folder didn't exist a couple of seconds ago. So now we are able to jump into this folder and take a look at some of those things. So again, you can make note of this. So you can take a screenshot, you can do whatever you want, but this information are in this folders anyway, so you don't necessarily need that. So I'm going to click on that, and then we're going to cd into root, roots, and then we're going to say, what was it, dot step, and then enter. ls. So you're going to see a couple of folders here. One, you have the certs, then you have the config, you have the db, secrets, and template. Template is normally empty. And then first we're going to do certs. This is your public search. So this one you can share or you can add to things. This is perfectly fine. So for cd into it, there should be 2 in here, right? So let's cd into cert here. Let's ls. And then you can see that we have our intermediate cert and our root cert. So if I was to do something like cat intermediate, you can see that this is our intermediate cert, right? And then if I was to clear that, ls one more time, and then say cat root, and this is our root CA. So remember what we talked about, right? So you have your intermediate certificate, and then you have your root CA, right? So you have both of those that have been created here for your certificate authority. So if we go back one, cd dot dot just means go back one folder. So we're going back to the step folder ls. And then now if we go to config, I'm just going to go into them one at a time. If we go to config here, so cd config, con. All right, and then ls, you can see that this here has like a ca.json, and it has a default. The ca.json file is very important. It has some a lot of information in there. Just make sure you're not sharing with people, just sharing that information that you have in your ca.json file. It defines a lot of things. So when step CA issue a certificate or signs a certificate, it kind of gives a date as to how long the certificate is valid for. So here is where you control that. If you want it to last for 1 year, if you want it to last for 2 years, this is where you configure it. And this is where you configure a lot of auto configuration in regards to how you want steps here to work. So just keep that in mind. So if you run into an issue like, I want it to do this, it's not doing it the way it's supposed to do it, this is where you need to go. And then of course you have the default. The default is just kind of default configurations in there. So I'm going to get out of this. So we're going to do cd.dot one more time, and I'm going to do ls. And then you have the db. This is just a database. You don't have to really go in there. And then you have the secret. So cd secret. Now this is very important. This is your private key. You do not want to share this. I know I sound like a broken record. You do not want to share your private key. Your private key is very, very important. You want to back up your private key and make sure you have a copy of it offline. So back it up. Do not share it with anybody. No, unless, of course, say you have your sysadmin, then because you have to share it, though. But do not share it with anybody. This normally stays on the computer. This is what the computer used to decrypt, just like we talked about. So now you stand to see the configurations, right? So the client encrypted, it sends it to you. And this is what you use to decrypt that information. So it's very, 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 very important to make sure your private key is private. And that's why it's called a private key. So just wanted to say that. So just don't share this with anyone, and make sure you back it up. And let's get out of that. And the rest one is just template, and there's nothing really in template. So these are where you find the config file. So root, then dot step. Anytime you see a dot in front of something, it means that it's hidden. So if I was to do ls right now, you wouldn't see it. So sorry, go back, cd dot dot, enter. If I was to do ls, cd root, sorry, I got out of it. If I do ls, you won't see that file, right? Because that file is hidden. But if I was to do ls -la, now you see that file. So the dash in front of anything just means that that file is hidden, and it's not normally seen when you do the regular ls. And there's a reason for that. You don't want people to just be jumping in and finding things, right? So just keep that in mind. But anyway, this is where the config is for this file, and this is where what the process is for initializing our certificate authority. Now we have our certificate authority. There are a couple of things that we need to do, so let's jump into those. Okay, so the next thing that we need to do is that we need to create a systemd service for Step CA to ensure that our certificate authority runs automatically and reliably in the background. Because without it, the CA won't start at boot or recover from crashes. And since the CA's private key is encrypted, we'll also need to tell systemd how to provide the password at startup because it can prompt for it interactively since it's running in the background. All right, so before we get started with the process, let's first take a look just to make sure that there is no systemd service that's running for Step CA. That shouldn't be the case because we haven't created it yet. But let's go ahead and take a look just to kind of make sure, because we'll look at it before and then we'll look at it after we've gone ahead and create a systemd service. So to check that, we can do something as simple as system systemctl tus step -ca. So as you can see, it says unknown. There is no Step CA service. I don't know what you're talking about here. That's basically what it's saying. Okay, so we know that it's not working and it doesn't exist. So the first thing that we need to do is that we need to create the password that we talked about earlier. The reason for that is because your CA, like I said a few minutes ago, is that the CA's private key is encrypted with a password. That's the password that we created when we were going through the initialization process. And that password is needed to decrypt the private key before the service can start running. And if we were to create the systemd service now without providing that password, when we start systemd, it will fail, and we don't want that. And the first thing that we need to do is to create that password. And to create that password, we want to go into the Step CA folder. So it's in the root, right? And then it's that step. And then ls, and we're going to create a password.txt file here. Now, a few things that I do want to say about this password before we create it is that normally, even though we're going to change the permissions so only the root user have access to this file, normally it's not ideal to save your password on the local computer, on the server, on the container in our case, right? Because if someone was to get access to, let's say, your root user, then they have access to that password. That means that they have access to your CA, which means that they can generate certificates, then sign them, so on and so forth. A whole bunch of issues can happen there. So ideally, the way it should work is that you have something like HashiCorp Vault, and then once you want to start the service, your CA will go to HashiCorp Vault, ask for the password, pull the password down, save the password in a temp file, use that temp file to start up the service, and then delete that temp file. Now, we can't do that because we don't have HashiCorp Vault set up in this environment yet. So for now, we're going to do it this way. And then when I have HashiCorp Vault set up, which there will be a video about that, we're going to set it up so that our certificate authority is pulling the password down from our vault instead of locally having the password on the container itself, because that's the best way to go about it. Just wanted to kind of clarify that before we do this. You can do it this way, but just keep in mind that this is not the most secure way to do it, right? So to do that, we're going to go ahead and say nano, and then we're going to say password id.txt. All right, so we're going to call this folder password, this text file password.txt, and then click enter. And then in here, again, you're going to paste the password that we created during the initialization process, because again, that's needed for the service to start. So you're just going to paste that in there, right? Like so, with no comma, no nothing, just paste it in there, and then just click Control X. Again, this is a password that you do not want to be giving this password out to anyone at all. So please make sure you secure this password. This is not a password that you should be giving out to anyone like that. The next thing that we want to do now is we want to change the permission to this password file so that the only person that have access to it is the root user. That is one way to protect it, but again, as I said, if someone have access to your root user password, then of course they have access to this file, right? And we don't want that, but we're going to do that anyway just to be safe. And of course, as we build the environment and we have HashiCorp Vault installed or some sort of Vault system installed, then we'll go ahead and pull that down from there. And I will talk about that, and I'll create a video about that as well. So for now is chmod and then 600, and then I want to do the password.txt file. Basically going to change the permission to the password file. And then once that's done, that's good to go. Now we have our password file ready and good to go. So the next thing that we want to do is we want to go ahead now and create our systemd service. So our systemd service basically allows Step CA to run automatically in the background. It allows it to be able to start up on boot. and it also allows you to be able to manage reliably like any other system service. Systemd is the service manager on most Linux system. So by creating a .service file, we're telling systemd how to start, stop, and manage step CA processes. And that's what we need, because we don't want, when we restart the server for step CA, not to come back on or not to work the way we want it to work. So to do that, we need to create the systemd file in the systemd folder. So that would be this guy right here. So basically, Nano is an etc systemd systems, and then we're going to call it step ca.service. So we're going to click enter, and then what I'm going to do is I'm going to bring this guy over, and we're going to talk about what each of this stuff means. So this is what the systemd service config look like. It's very straightforward, nothing too complicated. So first on the list, you have the description. So this is basically just a short description or short label for the service. And then here you have after equals to network.target. Basically, this makes sure that the network servers are up and running before step CA can start. And then here you have the service, which we define in the service type. We have the type, which is simple. And then we have the exec start, which basically just points to the directory for step CA. And then we point to some of the config for step CA as well. And then, of course, it points to the password file. So this is what is basically responsible for starting step CA. So this is the command that goes in and look for the config file, look for the things that it needs to see to be able to start step CA. And then, of course, it looks for the password as well to be able to say like, oh, I'm starting step CA. I need the password to be able to decrypt the private key and to be able to get all of the config that I need to get running. So this is basically what this is, right? And then, of course, you have the working directory. This is basically just a directory for step CA. And then saying that, do you want step CA to restart? If it crashed, then that's always, so that means that yes, always restart if it crashes. And then it tells you the restart second, which is 5 seconds to retry the restart. And this is basically just telling you that like, hey, have step CA start up on boot, right? So the multi-user-target is basically just a standard non-graphical target. And it's just basically saying that boot up when the server boots up. So again, pretty straightforward, nothing too complicated. So what we're going to do, we're going to go ahead and Control X, and that's going to save that. And then if we go back into it one more time, we see that all of these things are available in there. So we're going to do Control X one more time. So now the next thing that we need to do, Control C, we're going to need to enable the service now, and then we can start it. So the first thing that we need to do, we're going to do SYSTM CTL and ABLE step -CA. So again, one of the things to keep in mind, actually, before I do this, let's go back here. X, go. And as you can see, the name of the service is stepca.service. So when we're ready to do anything like enable it or start it, we're just referring to it like the name here, the same as the name here, which is stepca. So for us to enable the service that we just create, we're just going to say STM CTL enable STEP CA, and then that's going to enable step CA. And then the next thing that we're going to do, same thing, we're just going to go back here and say start, and then enter. That's going to start that. So now remember earlier when we did status, it said that service can be found, the server doesn't exist. But now if we were to do status, that's the ATUS, that service is up and running. So basically what we did is that we created a systemd service that is able to manage systemd. So if we were to reboot the server now, systemd will be back up and running. So whatever it is that we do, systemd is back up and running. Like I said earlier, in regards to the password file, it's not the best way to store your password. It's never ideal to store your password on the local server itself, but we don't have Vault set up yet. Once we have that set up, I will create a video as to how to pull the credential down from Vault and then use it and then get rid of it. That's a lot more secure, and it allows us not to be able to save any of the sensitive information locally, because again, your CA is very sensitive and you do not want to be saving a lot of this sensitive information just locally on your computer. So if I was to do see here, and then reboot, right? And it's going to do its thing. If it comes back up, we'll go back to cancel. So let's give it a few to come back up. It's asking us for password. We can skip that so you can access for the username. If we were to log in and then get in there, if we were to go back and say status, we can see that system CA came back up and running because that's what we wanted. I mean, sorry, step CA came back up and running because that's exactly what we wanted. So that's pretty much it. So now we have our certificate of 30 up and running. We have everything configured. And the next step is more so on the server side. Now, this video is already long, and I'm trying my very best to make the videos short. So this is phase one, but there's going to be a part 2 to phase 1 just to keep the video short, so it's not too long. All right. So in the effort of trying to keep these videos from getting too long, we're going to wrap things up here. We're still in phase 1, so think of this as part 1 of phase 1. At this point, we've got our certificate of 30 fully up and running. In part 2 of phase 1, we'll shift focus to the server side. We'll talk about how to generate the private key, create the CSR. If you don't know what that means, don't worry about it yet. We'll talk about it in the next video. We're going to talk about how do we extract the public key from that. Also, how we're going to use our CA to sign the CSR. And then finally, how to push the signed certificate to the server to ensure our communication is encrypted in transit. As always, thank you guys so much for watching my videos, and please do not forget to like and subscribe if you enjoy content like this. It really helps out a lot. And as always, stay geeking, and I will see you guys on the next one.